morning and welcome everyone to this Tewi Kolloquium. And I'm very happy to introduce very briefly Dr. Reza Farahani. As most of you know, he did his PhD here at the University of Klagenfurt at the Institute of Information Technology, where he continued as a postdoc in the Graph Massivizer European project, which is coordinated by the European Union. And in this context, he is aiming for his habilitation. That's why we are all here for his first talk in this process on sustainable and serverless service management on the edge cloud continuum. Reza, the floor is yours.
Thank you so much, Christian, for the nice introduction. Hello, everybody. Good morning. So I'm happy to be here. First of all, I would like to Happy New Year to all my Iranian colleagues. So right now is our changing year. So as Christian mentioned, the title for today's presentation is Sustainable Serverless Service Management on the Edge Cloud Continuum. So I will make my introduction brief since already Christian mentioned that. I'm a postdoctoral researcher and lecturer at the same institute, Institute of Information Technology, where I'm doing my postdoc in one European project. My role in this project is working package 5 co-leader. Also, I'm working as a tool leader. One tool, I will introduce it later, called Graph Choreographer. And also we have one federated computing continuum testbed in collaboration with my internal colleague here, and also external in the project. So my research interest, as you can see, the umbrella of my research interest here is distributed service and system management. Specifically during my PhD, I work on multimedia systems. Even right now, my first interest as application is multimedia, specifically multimedia networking. And now I switch a little bit for systems for AI, LLMs stuffs, and also on the always distributed edge cloud continuum. So I published around 35 papers. I mean, the published one also, submitted. Many was still on progress. Also involved during my postdoctoral time in European project proposal writing, also FFG1. So let's start. First of all, I would like to introduce our European project in collaboration with different institutes, also universities in 6 countries. So it's a big project. The coordination is here. And we started in 2023. Right now, we are in the finalizing part for just integration. So in the project, we promised to deliver 5 open source tools for big data graph processing. So it is the conceptual architecture of our project. So the tools started Inceptor, Scrutinizer, Optimizer, and Greenifier. Everything is just for big data processing. So imagine social media data can be represented as a graph, ontology one, and one partner just need to do the ETL pipeline, extract, transform, load, and another partners in the Netherlands just having some analysis regarding sustainability, regarding performance. And finally, my role here at University of Klagenfurt is just orchestration. As a last tool, Graph Choreographer focused for the scheduling, focused for balancing time and energy on the edge cloud continuum. So we created a testbed for that, and also everything based on Kubernetes stuff I will present in the next slides. So let's talk about, technically talks about today topic. So the agenda, my agenda for today is the world of application and services. I will briefly talk about different applications shape our digital world and talk about their concern regarding sustainability and performance, storage, and systems nowadays for serving such amount of data, and dive into serverless computing as an emerging topics for distributed system, what is its differences with traditional one, and also the opportunities and challenges. And dedicatedly talk about one of my recent paper called Heftless, Serverless Workflow Orchestration on the Computing Continuum, and dive into that topics and give some ideas for future direction. Without wasting time, let me talk about nowadays digital world. So as you can see, all of you are familiar with different kinds of IoT application, big data applications, from metaverse, from healthcare, LLMs stuff. Everybody nowadays work with ChatGPT like models, question answering, autonomous driving, diverse range of application with different requirements. But what is the challenges for nowadays applications? Such amount of data. They are very data consuming, computational consuming, hungry. So this one just shows the amount of data produced via such type of application, starting from 1.5 zettabyte to reaching 175 zettabyte estimated at the end of this year. So if I want to draw your attention to such amount of data, 175 zettabytes, so it is too much. Each 1 zettabyte is equals to 1 trillion gigabytes. So imagine you want to store such amount of data on DVDs. So what will happen? The stack would the moon 20 times or circle the earth 222 times. So it is too much. So we cannot imagine about that. And of course, for downloading such amount of data, one user maybe needs 1.8 billion years via having the internet connection, the download with the average download 25 megabit per second. So you can imagine what will happen. So what is the role of our countries, enterprise companies, specifically Austria? Every year, there are some data statistics shows that enterprise companies, specifically as the customers, as the producer for such amount of data, for giving such services, increase the usage of cloud devices, cloud instances, cloud services. So as you can see, for example, Austria 2021 just used 40.4, but right now, not right now, for the latest one, the latest statistic published 2023, the amount increased to 46.5. So in most countries is always like that. So they are depend on cloud services and cloud instances. Even you can see for all enterprise to large one, also medium one, a small one, every year they increase their requirement for infrastructure as a service, for just leasing some machines, platform as a service, also software as a service. So what will happen in terms of sustainability for our world? And also what will happen for the performance? Of course, cloud instances can give us many opportunities in terms of computation, connect to the online services. So providing accessibility, service diversity, high availability, high scalability, high reliability, all of that is clear. So at least much more better than local devices and local infrastructure, since the default tolerant can be better in cloud devices, cloud instances. Also the availability can be better. But what are the challenges? So what will happen for really latency sensitive application? So the application needed better performance metrics. So what will happen in terms of vendor lock-in? So if you are using AWS services or GCP, Google Cloud Platform services, you have to always use their services and their technology. So how is possible to connect different clouds together, or even your local infrastructure? So this is a problem of vendor lock-in. And another one, what will happen for really sensitive data in terms of GDPR? So what will happen in terms of cost optimization? So you are always rely on cloud instances, and you have to pay for such services. And of course, you need some administrator engineers always working with such complex technology. So let me briefly talk about some sustainability goals. So all of us know there are 17 goals for the sustainability, starting from no poverty, zero hunger, blah, blah, but in the technology, two main one is goal 7 and goal 9. For just improving the clean energy and industry innovation and administration. So If I want to give some brief statistics about, nowadays digital world, such amount of services, data production, so you can see the power consumption of data centers published by Nature 2018, so was greater than 1% of global electricity. I believe this amount, are much more than 2018 recently. So the water consumption in the data center for cooling down was about, in 2016, 625 billion liter per year. So you can imagine what will happen also in Austria. So European Commission published some statistic, also some estimation. The power consumption of data centers in Austria from 2010 to now to 2030 is almost will be doubled. So it is a big concern for such services on the cloud. Even nowadays everybody use ChatGPT like models, or cloud. There are different types of GPT based models for different tasks. A statistic shows that single response from ChatGPT like model nearly needs 10 times energy compared to Google search. And even it was interesting, recently I read one white paper shows that for just searching one prompt, you need 4 grams CO2 emission. But if you increase your searching on the ChatGPT and sending more prompt to 16, the CO2 emission will be equivalent to boiling one kettle. And even increasing to 90,000, it would be around travel to Seattle and come back to San Francisco. So it is too much. So it was the main reason why edge computing the role of edge computing can be bold and bolder than earlier. So what is edge computing? What is the innovations of edge computing compared to cloud computing? So there are not unique definitions of edge computing, so everybody defines that based on the requirement. I just brought one figure, shows even edge computing can be hierarchical. So computational node, storage node close to the base station in 5G, 6G literature, or even in your local organization. At your home, some IoT devices can be considered as edge computing for reduced latency, lower bandwidth usage, enhanced privacy and regulatory compliance, and offline functionality, as I mentioned, as the challenges of cloud computing. But of course, cloud instances are much more scalable and larger than edge devices. And we have to create a trade-off for offloading some tasks from edge to cloud and vice versa. So recently, with my colleague here at University of Klagenfurt, we switched to LLMs, services and LLM stuff. We had some preliminary, experiment with my PhD here. So we wanted to see what will happen in terms of sustainability and energy consumption, energy usage if we use some local LLM models on our local infrastructure. And as you can see, some results improved significantly for energy consumption per prompt. For example, Q1 as a model of LLM just need 47% less energy consumption than ChatGPT. Of course, it's clear since it's much more smaller, and we didn't create a big one, but of course many requirements can be limited to such edge usage of LLM as well. So it is exactly match with the goals of our country. Austria just focused for AI mission in 2023, just for the sustainability, better computation, and even how it's possible to create system for AI and AI for system, green for AI and AI for green. Just let me talk about combinations of edge computing and cloud computing. I mentioned benefits and pros and cons for both systems, but even it's possible to integrate them together, create a stack, hierarchical one. We call that edge cloud continuum. Somebody called that computing continuum. Having devices super close to the client side where data is produced, and even G-Node B going to the data center. Of course, it's the trade-off between scalability and some performance improvement, latency improvement, but shaping such type of continuum is one hot topic. The research question is here. If we integrated edge to cloud, offload some task and going from edge to cloud, how can developer just seamlessly execute tasks without the overhead of managing infrastructure, also for the resource allocation? If you remember in cloud computing, I mentioned that it is already complex system. So even if you add another stack, it would be much more complex than earlier. So how is possible to just having developer knowledge and using such system without having advanced protocol understanding and administrative perspective? The second one, what strategy can be employed to minimize execution cost? Of course, going from edge to cloud needs some bandwidth for just offloading. Also running in local infrastructure with zero cost in terms of economic cost, dollar, euro, or any kind of currency is good. But for cloud, we always have to pay per use model. That means even during the idle time, we have to pay that. So it is a little bit challenging to have at least a model actual pay per use or pay as you go. That means you only need to pay whenever you use one compute or storage or some other infrastructure. This was the main reason one promising technology called serverless computing emerged. So serverless computing in nutshell just is a paradigm in the cloud computing that try to minimize costs and just giving opportunity to developer to upload their code to the system without having any knowledge about management orchestration. So you as a developer, as a software developer, you have some application, just need to prepare your code, encapsulate it and upload it into the system. You don't need any knowledge and you don't have to be worried about scaling up, down, elasticity, and many challenges existed in the domains of cloud computing. But serverless doesn't mean no server. You have some servers, but you don't have to be worried about the infrastructure. You have to always focus on your work as a developer. So serverless computing includes function as a service, also backend as a service. That means you prepare your code, encapsulate, as I mentioned earlier, for example, in the container format or as a zip file, just upload via API into the cloud infrastructure. And cloud is responsible for providing different services for you in a serverless manner or traditional one. I mean, in terms of the cost model. So nowadays, there are many serverless platforms, from commercial one like AWS Lambda, IBM Cloud Function, GCP Cloud Function, Cloud Runs, to the open source one like OpenFast, Native, Fastly, OpenWhisk. So the question is here, how we have to select a platform and how it's possible to use such platform and benefits on the edge cloud continuum. So most of the companies recently, enterprise companies, just try to use the novelty of serverless computing for reducing their cost, optimizing their OpEx cost. Even in the container format, for example, AWS or GCP or even Microsoft Azure, their production. So the differences between cloud and serverless is about the cost. So you don't need to pay on the idle time. So you always pay actually per use of the compute node or services. So execution time will be main factor for the cost. Also memory allocation and number of requests. So it's a big achievement, no? But any kind of new technology brings some problems. So just I read recently some historic story about Trojan horse, and I just try to connect it into serverless computing. Serverless brings many opportunities for the application developers and companies, but at the same time brings some concern regarding some terminology called cold start, misconfiguration, vendor lock-in, and many others. So they use this Trojan horse, but they have to, think about such challenges as well. So what is each concern, in the serverless computing? Vendor locking. So vendor locking existed in the cloud computing, as I mentioned earlier, but here is much more bolder than cloud computing. Since here, you are limited, of course, to AWS Lambda, you are limited to GCP function, and in some cases, it's not easy to just migrate your services to another cloud. Connecting different cloud together and creating multi-cloud, solution or multi-cloud infrastructure for your application. So it is difficult for switching the provider, higher cost over the time, also restricted innovation since you are always located and limited to one cloud platform, serverless platform. Another Trojan horse concern and challenges was about cold start. So I mentioned serverless just try to optimize cost, but of course it's not free in terms of latency. So they just imagine about some container, some zip file, you store it somewhere in the Docker registry. It is not actually ready for the execution. So for the first time, whenever you invoke your function, you have to bring it from remote Docker registry. It imposes a little bit delay to the system called cold start. As it is clear here, for the cold start is for the process initiation, also for some system preparation. So all of that is considered as the cold start. So after the first time, it would be much more faster for the invocation. But one features of serverless was about the cost, since it can scale it to 0, scale it down. So even for the next invocation after some whiles, idle times, so it can impose some cold start as well. Cold start is a very challenging, part of the serverless computing, but it depends to many factors. Just setting, memory size for your function, piece of your application or part of your application. So regarding the code size, programming language, runtime, package size, and concurrency request. So I just, brought some result here that shows cold start could be different for the same functionality via different, implementation. For example, one of that is for the Java, another one is for Node. So you can see the differences in the levels of 300 milliseconds to 3.75 milliseconds. So it's a big concern. Another challenge that I talked earlier was about misconfiguration. So take a look at the first figure. So you can see user can just upload a video or photo to one storage, and a storage can automatically invoke another function just for producing some processing and producing some thumbnail, for example, and storing in another bucket in another storage. But what will happen if somebody wants to reduce the cost using one storage instead of two? So it creates some infinitive loop. Since users use SDK, just upload their photo here, so the photo in the storage can automatically invoke Lambda function for producing thumbnail, but again store it into the S3, for example, storage, and again it invoke another one. So it is like infinitive loop, but unfortunately it can increase the cost completely against to the serverless computing commitments. Also, make it complex in terms of storage configuration and other compute configuration. So all of these challenges even can be bolder and increased when you are working in the domains of workflow, not a single function. So in the workflows, there are some dependency. One function can feed another one. So your application nowadays is not based on single, function. Imagine you are working on LLMs, so you need to connect it to RAG, to another, parts or innovation. Even you working with your company on the application, so it needs different services and different parts. So it can be much more difficult than single function. So nowadays application, most of them are based on DAG, acyclic graphs. So you can see, what will happen for the complex application. So there are some papers, there are some, products for just processing even scientific workflow in the domains of serverless computing. So there are, of course, some commercial, technologies, workflow management like AWS step function, Google, workflow, but they are, they suffer from the previous challenges in terms of vendor lock-ins and, configuration. So this was the main motivation in the, this habilitation talk. I focused for serverless, presenting some idea regarding, serverless and challenging. Every year there are some results from the Gartner, so you can see I'm here using edge cloud computing, serverless computing, and you see the deployment risk, the enterprise values, also the adaptation phase. So serverless computing in combination with edge cloud computing is a really new topic, and it brings, many challenges and opportunity for the communities. But we have to be careful for serverless workflow. If you want to jump from, cloud computing directly to serverless edge cloud continuum, so you will fall down here. So the design should be precise, at least comprehensive, for having such type of system perspective. So I reached to this point. Right now, I would like to talk about one of paper recently published in IEEE International Conference on Cluster Computing. Actually, it was in September 2024, and after that, I have other, publications and submitted. But I would like to bold the result of this, work. It was in collaboration between 3 universities: Salzburg University, also University of Innsbruck, and Radopurdan here at our department. So let me talk about motivation for designing such type of workflow batch processing called headless. So imagine a simple scenario. You have one application. Your application is very simple, but not first single function. Two simple function, sequentially connect them together. So first function just invoke the second one, and you have set of requests. Request 1, 2, 3, 4. So different users in different geographical location maybe ask for just running the application. I don't know, for producing that thumbnail, for example. And also imagine one infrastructure, very simple one, computing continuum, including 3 instances: cloud, fog as an intermediate between edge and cloud, and also edge computing with different capabilities in terms of concurrency limit, in terms of time, cost for processing, on the cloud, on the edge, on the fog, also for some deployment, time or latency, also for the cost of that. So regarding, cold start, what I mentioned earlier, if as the first time you want to deploy onto the system, what will happen? And consider some scenarios regarding deployment. Nowadays, all serverless computing infrastructure platforms work based on one technology called pre-deployed scenario. So what is pre-deployed scenario? That means you as a developer, first of all, have to, upload your code, deploy your code on the infrastructure, AWS, Lambda, GCP, and after that it would be ready after some seconds for just, invoking that. So consider a scenario for such application. 3 seconds, you would like to, have the final result from function 2. So we want to check together what will happen in terms of scheduling orchestration. If you put all instances of your, functions, your application, on the cloud, what will happen in terms of cost, in terms of latency? Of course, it meets 3-second deadline, but it needs $60 based on our assumption here for just processing and serving your request. If you use other instances at the edge of the network or on the fog, so what will happen in terms of cost reduction? So it can reduce cost into $8. Also, again, some challenges are, will happen in terms of deadline meeting. So it violate the deadline. It cannot meet 3 seconds since, processing at the edge, also at the fog, needs much more time than, commercial cloud. But what will happen if you balance cost and time? A little bit increase the cost in terms of such type of traditional approach for edge cloud computing. So you can increase it into 10 seconds, but having one scheduling at least for meeting the time. So meeting the time is really important, since some users maybe leave your your software solution since it's violated, and you have to pay penalty based on service level agreement. So it was the first scenario for pre-deployed. But what will happen if you do not have any deployed functions at the edge, cloud, or even FOC? So it's not the part of function is not ready, part of your application is not ready for the invocation. So nowadays cloud platforms cannot work based on that. So imagine a scenario: edge device doesn't have any functions, any deployed one. FOC has both function, and cloud instance only have the first function. So I would like to investigate the scenario to see if I design a new deployment solution methodology, what will happen for the system in terms of cost, in terms of latency. So you can see on that scenario, if we want to limit ourselves to the pre-deployed model, so we cannot use edge since there is not any deployed function. We can use both F1 and F2. At the fog of the network, also for the cloud, only using F1. So the deadline would be 4.5. Also the time, the cost is $10. But what will happen if I download the function, new one, from Docker registry, from local registry, as a container pool, and just deploy it at the edge of the network using all functions together for decreasing cost into 8 and meeting the deadline in this time for 4.5. So it is a new innovation, at least in the domains of edge cloud continuum in terms of deployment. So the main research questions for the paper we wanted to investigate on that time was: how can serverless workflow batch orchestration be designed across the entire computing continuum? How is possible to consider some constraint from different layers of the continuum and manage as much as possible functions and application functions, workflow, set of applications, so here concurrently, and of course considering some partial function deployment, not like the previous model, for balancing time, cost, using via computive, also data intensive workflow ones. So, but of course it was very challenging, since it brought other research question, wie Frage. So what function we have to upload? So why we have to upload? When we have to offload to another layer? How is possible to use pre-deployed or fully deployed model? And which which part of the continuum has to invoke another one? So it brings many challenge in terms of implementation. So considering such research question, we designed one architecture called Headless. So I will explain the modular part of the architecture. So as an input of the system, we need set of applications. So this is the main reason we mentioned that workflow batch orchestration. Since it's like a batch of workflow, so it is not only the single function or single application. We wanted to connect many applications together and then see the response of the system in terms of time and cost for processing. So for concurrent processing. And designing headless orchestrator as the key part of the architecture for monitoring resources from the compute continuum, also receiving some information from the workflow, parse them, designing one scheduling solution, and connecting different platforms of serverless, open source one, also the commercial one together, for just having better time and cost on the computing continuum. 3 full layers of computing continuum, including storage, including compute nodes. So regarding the problem formulation, since I talk about the challenges, so it was really important for us to just formulate the problem in a scientific optimization model language, considering different constraints in terms of workflow model. So single function, one workflow, multiple workflow needs to serve concurrently, considering compute, storage, bandwidth for modeling continuum, computing continuum infrastructure. Partial deployment, no deployment, the traditional one as a pre-deployment modeling, execution model for just considering cold start stuffs as I mentioned earlier, for compilation time, make a span for the whole batch of the workflow. Also considering the cost in terms of computation, in terms of storage, in terms of bandwidth, and finally there are many resource limitations entire the computing continuum. So if one instance doesn't have enough capacity for running something, so what will happen and how is possible to offload tasks to other instances regarding that VFOG that I mentioned earlier. So the optimization was based on bi-objective integer linear programming. So one term in the objective was workflow batch time, and another one was workflow batch cost. For multiple sets of workflow, as I mentioned earlier, and considering 14 constraints. Here I didn't bring the mathematical language here since it's out of the audience scope. So here just designing one decision-making variables in our optimization to see we have to go from one instance to another one for selecting one storage, and also selecting one modes in terms of deployment or pre-deployed or non-deployed one, and also selecting the time for function offloading, which function has the highest priority for going to another one. Since it was time consuming just for running in a practical scenarios, we had to design one heuristic solution. So here we use the idea of heft, very popular heuristic algorithms in the literature. We combine it with the serverless computing and design one non-preemptive scheduling approach just for finding the instance for running a function, the storage for storing the data, for just clarify the priority between function, between workflows, and entire workflow page in different phases for sorting, ranking, scheduling, and updating. And the time complexity was on that big O, so it depends on the numbers of compute instance, numbers of storage servers, also the size of workflow batch. But it was much more faster than previous optimization model. Before diving into the result we achieved, I would like to highlight some designs with some of my colleagues here. So regarding the compute continuum. So in the paper we use AWS Lambda. We use one European provider called Exoscale in collaboration with ITEC, and also different edge devices. So Jetson Nano for providing some GPU capacity capabilities, also different types of Raspberry Pi, and also twin servers in our server room, so which connect them together for shaping the infrastructure in 5 different geographical locations: Sofia, Frankfurt, Vienna, and local infrastructure at AAU. But of course we have AWS Lambda in US region as well. So the testbed software stack mainly is based on Kubernetes. Kubernetes is the platform for just managing the Docker container based applications. So in this domain, serverless computing platforms like open source one, OpenFast, which installed right now on the edge devices, Raspberry Pi, Jetson Nano, are top of the Kubernetes. So we use different types of monitoring tools for for energy measurement, for performance measurement via Kepler, CNCF Kepler, Prometheus, visualization via Grafana, some real-time measurement via Catvisor, Docker registry, MinIO, and different types of setups for creating our testbed. So this is one cluster of our testbed. which is in my office right now, connecting, using two HP servers for, creating different cluster of edge devices, connect them together, via Jetson Nano and Raspberry Pi, and creating such, testbed, such cluster for our heftless validation. So you can see everything is connected under the DPS. I call that DPS. DPS is distributed system master node. So all Raspberry Pi Jetson Nano are connected to that one. So it creates one Kubernetes based cluster for edge domain, but even for the commercial cloud, we use their dedicated Kubernetes one and create some scripts for connecting different layers together. I would like to highlight some some figures regarding our measurement, at least for the monitoring, since the system depends on the monitoring information from receiving different energy, also in this work on the performance from different instances. So we needed to know about kubelet, as the big umbrella and one main services of Kubernetes, parameters and metrics going to the cluster. So each cluster, which type of information we have regarding CPU, memory, and even some bandwidths and some thresholds. Going to the node, so in each node, in the master node, in the worker node, so we have such information regarding CPU. I just show the visualization here, but we have some scripts for just extracting in a real-time manner via Catvisor. So even the container monitoring, the pod one. So we needed to have everything regarding monitoring, and based on that, having some wise decision making. So testing the heftless needed some realistic applications. So we designed two applications. One of that was workflow based on video processing, using some machine learning based inferences here, and finally deliver the result in terms of, object detection, in terms of some categorization of some, deriving signs to the end users, also for sentiment analysis. So we receive big data from the Amazon customers and just wanted to having ranking, saying positive or negative feedbacks for the application, including multiple functions here with different computation, bandwidth, and resources, and comparing result with different state-of-the-art solutions. So one of that was Serverless, another one was SchedulX. Also, we created some baseline based on the BLP that I mentioned earlier. Also, the first mode of the heftless, which means it doesn't need any new deployment. Everything is deployed on the system. If the function is not existed somewhere on the continuum, so it cannot run. The instance cannot run that. So the strategy for the serverless was just allocated first function execution to the edge, and after saturating the edge layer, going to the next one. Also for the SchedulX, it was based on the execution time. Longer one are reserved for going to the cloud, and shorter function in terms of execution time go to the lower layers. So first of all, we wanted to see what is the execution time of BLP and our heftless heuristic algorithms, just by increasing numbers of functions, also workflow batch. Starting from workflow batch with size 10, 15, 20, and increasing to 30. So it needs, you can compare in terms of execution times of the algorithm. So it was not possible to running everything based on BLP, and it can clarify why we designed such approach, as a heuristic one for running on larger scale scenarios. Performance analysis shows that even heftless could decrease the cost super close in the smaller scale scenarios with that amount, 50 workflow batch size, decrease the economic cost, also the completion time. But it was not possible, as I mentioned earlier, to run everything in such a scale. We wanted to scale scenario and see what will happen in terms of total cost, workflow batch cost, also total completion times. So seeing if the size of workflow batch is 100, 200, 300, what will happen in different state-of-the-art also. Also our solution heftless. So you can see again we had some reduction here But of course, in some scenarios is competitive since it needs some cold start for running, some functions. And you can see offloading task and running task in different layers of the computing continuum, and even in a scale, it can use, undeployed function much more than, a small scale scenario with 100 workflow batch. So it means that deployment methodology was useful in larger scale scenarios, much more than a smaller scale one. And the final one, just seeing what will happen if we set some strict deadline for the system. If the deadline for video processing application in the batch set for 150, what is reactions of different systems for meeting that deadline? So you can see the edge-based serverless cannot meet the deadline even in 100 workflow batch. But what is reactions of heftless mode 1 and even mode 1 plus mode 2, the green, in scale scenarios, and even for the second application sentiment analysis. So it shows it could outperform baselines based on such metrics. Future direction. So we reach to this question. Nowadays everybody talk about serverless, combining serverless with different application management, workflow management. But what will happen, what comes after serverless? So you see, somebody just say codeless, somebody deployless, CPU-less, but even for the future, it would be much more challenging than now. And my current submitted paper, also, current research is based on some modern application with much more complex, shape based on LLM, using deep reinforcement learning for decision making, having some prediction for proactive monitoring, and in some cases having much more wise decision making via such solution, and considering energy and carbon footprint, balancing carbon footprint and energy in different geographical zones for reaching the objective. So still I'm Reza Farahani, so it's the end of my presentation. Thanks for listening. I would be happy to answer all of your questions. Thank you.